Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're over here at my Monarch Model K lathe, and I'm getting ready to set this thing up to do some turning of some tapers. And I've got I got a job coming up that I need to be doing on my Kearney Tracker Model 2D milling machine. And I got some special tooling that I need to run on there that I don't have any type of arbor to mount to. And if you're familiar with the 2D rotary head milling machine, it is a rather unique machine. It takes a special taper to fit up into its spindle that was pretty much only used by that machine. You can still find some stuff if you look around for it, but it's getting really hard to find it. And a couple of things that I need, I don't know that they ever made it, but we're going to make some. So to make this taper, this is basically, it's a 30 taper, but it's kind of modified from a typical 30 taper like you would have in, say, a modern CNC milling machine or something, and that it has some slots in it. It actually is tightened from the bottom rather than from a drawbar. But the taper part is the same as the 30 taper. And that taper is basically 3.5 inches per foot. So that's the taper here that we're going to be working with. I've got at least 2 different arbors that I need to make that have this taper on it. And the process to do it is that I will come over here, I'll rough them out on the lathe, a little bit oversized. We're going to actually do a heat treat on our material, and then I will finish grind them on the Brown Sharp model number 13 tool grinder that I have, universal grinder that I have, which is kind of the reason that I picked that machine up, was to be able to do some of this taper grinding. So today what I want to do is I want to get my taper attachment set up, and I think that since I've got multiples of these to do, and there is a fairly good likelihood that at some point in the future I'm going to have a need to make another special tool for this thing, that I may have to set up to do this again. I think the first thing I'm going to do is actually make a setup arbor that I can use that has this right taper in it, that will make setting up the taper attachment here on the lathe easier, as well as setting up the taper on the grinder easier later down the road. The setup bar is basically just going to be where I'm going to turn a taper that's at the taper that we want, and have it dialed in really, really close to where it needs to be. I mean, exact, really right on the money. And that way, when I get ready to do it next time, I can just put my setup bar over here on the lathe or the grinder between centers, and using an indicator, just kind of indicate it in. That's kind of the game plan. So that's going to be today's job, is making that setup gauge with basically a 3.5 inch per foot taper. So before I can get started on it though, if you guys watch the channel regularly, you know we just did some modifications to a part here on the taper attachment to kind of fix it and make it a little bit better. There's one other little thing that I need to do. I actually, and I'll show you this here in a minute, but there's a dial on here that is used to read what the taper is that you're setting to. And mine is just a little disc that has the either degrees or taper in inches per foot marked in there, and that it's not going to get you exactly on the money, but it's going to get you really close in the ballpark. The little disc that was on mine originally was so worn you couldn't read it anymore, so I had a new one made, and I'm going to show you that. We're going to go ahead and get that installed, and then we're going to go ahead and get this set up to cut a 3.5 inch per foot taper. Let's get at it. So back here on the taper attachment, there is a place where this little metal disc drops down onto, and it is pinned to this gear on this rack here, that as you turn this, you can read the inches per foot or the degrees up here at the top on 2 different scales that are on here. Again, the problem is, and I don't know how well you can see that, but that is just so worn and pitted that it's just you just can't read it. It's just a mess. So I had my friend Tom Utley at Von Industrial, who does reproduction tags and stuff for me. He has a laser engraver. I got him to actually make a new disc for me using the original. I sent him the original, and it is still faint enough that you can kind of read it, but it's just not very clear. But he took that and was able to recreate a new disc for me. Now there's 2 little holes here, and the way this works is you got a special nut that has 2 little pins in it, and that fits down over this those two little pins go in there, and then this actually fits over this, and there is a hole through here that a pin pins it in place. So I need to start by figuring out exactly where we need to go. Put this on. There's two ways it can go, and I need to make sure we're going the right way, and I think it's going to go just like this. It is. I'm going to go ahead and kind of get a little hammer to tap that down there with. All right, I'm going to kind of get my hole kind of lined up there a little bit. Get that down on there. Take a tapered punch here and kind of get that lined up. Okay. And there's a pin that will drive through there and pin it all in place. Get that flush. There we go. And you read your inches a foot on the outside scale. You read your degrees on the inside scale, and there's a little cover here that kind of reaches down to that. Let me get a right Allen wrench to tighten that up. Hex key. Get these tightened up. And now I can read that. So right now it looks like it's set on between a little over ½ inch, between 1/2 and 5/8 of an inch per foot. We need to go to 3.5 inches per foot. So let me go grab the wrench. We'll loosen these up and we'll get that set. Now to adjust this taper, there is a nut kind of on the bottom that tightens and loosens, and there's also one on the other end. I'm going to loosen them both up. And then you can use this one to actually change the taper. And let me figure out which direction I want it to go. I think I want it to go pulling in this way. So I'm just going to pull this around until I get, I'm right at 3 inches right now. A little bit more. That's 3.5 inches according to the gauge here, the dial. And we're going to make some measurements and verify that, but this will at least get us in the ballpark, or should, assuming everything is set the way it's supposed to be. Tighten the other end up first so it doesn't move. Alright, so that is now set on 3.5 inches per foot, and we can put some metal in there and start actually turning it and see if that'll work. It's just kind of verifying things. Here's the part that has the taper on. I'm just going to put that up against it, and if you look, this is running more or less kind of parallel with the ways, so I think we got our taper again, at least again close. It's probably going to take some fine adjusting to get it right where it needs to be, but that's going to get us close. And now I went ahead and tightened up the nut right here, which kind of connects the cross slide to this taper here. So now when I move my carriage, instead of my hand wheel moving the carriage in and out, it's locked. It's going to follow that taper. So as I move the carriage away from me, you're going to see the cross slide move in, and you can see it doing exactly that. And when we go in the other direction, it does the same thing. It's moving out now. So we've got our taper set up, we need to get some stock in here and start making our little template, and we'll start checking that taper as we cut it, make fine adjustments to it once we start cutting. So I cut me a piece of stock about 6 inches long. This is 4140 steel that we're going to make this from, and we're going to do this between centers. So I'm going to start by facing each end and putting a center hole in there. Then we're going to get this set up between centers so that it will easily go over on the grinder, and we can move it around from one machine to the other. And anyway, so I'm going to go ahead and get my centers in here and my ends faced. Just come in here and touch off on this and just face that with nice clean surface. That cleaned up, and it did. Bring the tailstock in here. I've got a center drill. We'll go ahead and drill our center. All right, that's that end. And we will take this out. Flip her around and put a center in the other end as well. Now what I'm going to do is I'm going to put a center in here. This is just one that I use on this, and to make sure it's running perfectly true to the spindle, I always touch it up each time I use it. Just turn it. So I'm going to move my compound around to 60 degrees. We'll freshen that up, and I'll have a nice center on this end. We can put a live center in the other end and put this between centers. So let me get that trued up real quick. So guys, I think I missed that on camera, but basically what I've got here is I just set my compound up to 30 degrees, which is half of 60, which is 60 is the included angle that we want. And I basically just turn this right here on the lathe, and that right there will give me a perfectly aligned center on the headstock end. With the 3-jaw chuck, you're probably never going to get running perfectly true, but with this method, it doesn't matter if the metal's running perfectly true, because it's been turned. The center is running perfectly true, and that's the main thing we worry about. All right, we're going to get this set up between centers and start turning our taper. So I've got a dead center in the chuck up here. This will be turning with the chuck, and we will drive it off of one of the jaws of the chuck. On the other end, I got a live center. This will spin. I've got my work now of the center on both ends, and I've got a drive dog on here. This drive dog just clamps to the part. And when I put this in place, I'll put it up on this center. The jaw comes in contact with the chuck here in this case, and that's what's going to drive it. I'll bring my live center in on the other end, and now this part is turning between centers. The advantage of working between centers like this is you can take it from one machine to another, set it up on the centers, and it's going to be running true. Whereas if you put it into a chuck, like I mentioned before, with a 3-jaw chuck, it's never going to run just absolutely perfectly true. You can fine tune it with a 4-jaw chuck, but then every time you take it off of one machine and put it on another, you have to go through that process again. Because we're going to be turning this, roughing it out here on the mill, or lathe rather, and then going to the grinder to grind it, I need to be able to take it from one machine to the other easily. In between centers is the easiest way of doing that. All right, I think we got this set up. Let me get my taper attachment ready to go, and we're going to start cutting some tapers. So to get my taper attachment going here, I want to get my tool kind of where I want it here as far as left to right and so forth like that. I also want to go ahead and kind of bring it up till it's touching or real close to touching, because we will have to make our further adjustments in the compound to actually feed in. And if I wanted to, I could set this at 90 degrees. I'm just going to leave it here. I'm not so much worried about taking a measurement on it. We're just going to get this to clean up right now, so I'm not too worried about that. Also make sure I got it back, my compound back, where I got plenty of adjustment in it. I think we're good there. There is a bolt on my lathe right down below this. This will tighten the nut up to the taper attachment, so now I can't move it with the cross slide anymore. It's locked in place and it's following the taper that we've got set up on that bar back there in the back. I also need to come around to the back and tighten up the lock that locks the taper attachment in place. That's going to keep this section locked down in relationship to the lathe, and now when the carriage moves, it's going to follow this bar that we have already got set up on the taper we want, or at least close to it. So now when I move the carriage, it's going to follow the taper attachment, and we are ready to start turning here. So let me go ahead, I'm going to fire things up. I'm going to engage the taper attachment. It's going to come along and it's just going to hit right there, but you can see it real quickly came out. So I'm going to come back in. I'm going to feed in a little bit. We're going to take another pass. This is a 3.5 inch per foot taper, so it's a pretty steep taper. As you can see, it starts feeding and then it quickly kind of disengages there. Let it take another pass. I'm going to do this several times until I get a little over an inch of material kind of cut. Then I'm going to get my taper micrometer and start measuring the taper. And I've been working on getting this turned, and I will note that I'm getting a little bit of irregularity in this. It's just a little kind of a, I think it's just where the rack on the gear is just kind of transitioning in here. It's not a perfectly smooth finish, but I'm not too worried about it because we're going to grind this on the finish, and I'm going to leave material on here to grind. But I do want to see if I'm in the ballpark on my taper, and to do that I am going to use a taper micrometer. Now, a taper micrometer is kind of like a sine bar that's on a micrometer bed here. So you basically come in here and you get all 4 pads touching the work, and when you do, you can read off of your micrometer over here how high up it is compared to 0. And right now it looks like we are at, let's see, all right, we're at about 289, and to be a perfect taper, it needs to be 291. So I'm within about 0.02 of per inch. It's not a perfect taper, but again, we got some irregularities in here. I'm just trying to get a rough tapered on here. We're pretty darn close. We will wait until we get over on the grinder and we'll actually get it dialed in over there. But for roughing purposes, I think we're good enough. My goal right now, guys, is because this is going to be a test bar, I want to have as long of a surface that I can sweep on here. So I'm going to take it down pretty small diameter over here, which is probably going to have my taper coming out along in here, and that will just give me more area that I can sweep on a dial indicator when I'm setting it up on my grinder, or over here on the lathe to dial in that taper in the future. This is just going to be a reference taper for in the future. So I'm going to continue turning this down a little bit more and until we get where we need to be. Well, disaster has struck. If you guys watch the channel regularly, you will know that this clamp back here is the clamp that holds the taper attachment in place, and it had previously kind of busted off a little piece in here, and was not clamping down very well. I repaired that by milling out and putting a little ear in there and or putting some screws and pins to hold it in place. But because of that thin cross section, and probably added to the disaster there with the extra holes in there, and honestly, I am really seriously wondering if my repair was not prone for failure from the beginning, because if you look real carefully, I don't know how this shows up on camera, but this little piece here and here, there's some discoloration in the brake, which kind of indicates to me that there might have been a hairline fracture in there before I even started on this, from the original breakage of it before I ever did my repair. Now, when I did the repair, I couldn't see any fracture in there, but usually when you see discoloration in a crack or rust in a crack, that's a sign that there was a hairline fracture there, and either water or oil or something has seeped in there over the years. So I think it had a little bit of a crack in there, and then when we put some pressure on it, boom, it busted. And I'm thinking this may have been why I was kind of seeing that little irregularity in the machining as we went as well. So this pretty much puts me out of business on the taper attachment for now. So game plan, I'm gonna have to make a new clamp. The original here is cast iron. I could make patterns, send them off to the foundry, have them cast, etc. But honestly, guys, I need this taper attachment, so I'm probably just gonna fabricate something out of steel, which will be quicker. And yeah, I think that's just kind of where we're at. But as for my taper turning today, we're done. And it actually, I'm not sure if we can salvage the part. Let me show you what happened there as well. So whenever it failed, it was cutting along, and then all of a sudden we lost everything. And I didn't hear it, I didn't notice it at first. I kept saying, man, that cut looks like it's getting deeper and deeper and deeper. And by the time I realized what was going on, I'd gone in there a pretty good ways. So I'd have to basically turn all that out. We may be able to salvage that. I may have enough material in there that by the time I get turned in there, we've not too much on a point down this end, but we'll see when the time comes. But before I can do anything else, we got to fix the taper attachment. We got to make a new clamp, and that's not going to be in this video, but that's going to be coming up soon, I guess. Well, guys, with the taper attachment on the lathe being out of commission for the time being, and until I can get a new clamp bracket made, I think what I'm going to do is I'm going to run out to the museum. They've got the Lodge and Shipley 16-inch lathe out there that has a taper attachment on it. I've used it for doing tapers before, and I'm just going to get this job finished up so that I can kind of move forward on this project, because I just don't have the time right this minute to spend a day and a half, however long it takes to make a new clamp for that machine. So yeah, we're just gonna, I don't even know if I'm gonna be shooting video. It's just hard to shoot video out there at the museum. I've got all my stuff set up here in the shop, and move everything out there's gonna be a pain. So I'm probably just gonna go out there and sit there, taper attachment up. You've seen the process, the same thing, and go ahead and kind of finish getting this turned out so that I can have this ready to heat treat and go to the grinder. So let's see how that goes. I'll be back. I'll try to catch a few little video clips if I can out there, but we're just going to try to get this thing finished up. Well, guys, as sometimes is the case, things don't go like they're supposed to. Today, things did not go like they're supposed to. You know, you can get upset about it. You can sling tools across the shop. You can say ugly words. You can do everything else, but at the end of the day, you still got the same problem. So, yeah, we're just going to have to get in here and fix it. It's not the first time I've had to make repairs to keep these old machines running, but definitely going to have to do that today. Unfortunately, you know, well, I might be able to call up Monarch and just order a new one. I don't know. I haven't tried, but based on my experience, it's going to probably cost as much as the lathe to get that part. And the advantage of having your own machine shop is that, hey, I can make it. You know, if I was making it for someone else, it might be cost prohibitive, but if I need it for myself, you know, it's just time and materials, which is expensive, but yeah, that's probably the route we'll go. Well, guys, we didn't get to the finish line on this project. Instead, we created a new one. So we got a new project coming up. I'll get on that as soon as I can, come up with a game plan, and I'm sure you'll be seeing that soon. So guys, with that, that's going to be a wrap. As always, thanks so much for watching. Please do subscribe to the channel if you haven't already. Those thumbs up, those comments, they really help out a lot. Big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships. All of those methods really do go a long ways toward really making things a little bit better around here and helping me to justify to take the time to shoot these videos and bring them to you. Guys, with that, we're going to get out of here. We'll catch you on the next video. Again, as always, thanks for watching.